Okay, we're in section 4-2 today, where we're going to solve differential equations that were perfectly okay to solve by some other method using Laplace transforms. Now, if you look at the Laplace transform table that I passed out, you'll see that it has some cool things on the top there. And one of those cool things is that if I take the Laplace transform of the first derivative of something, then that's going to be s times f of s minus f at 0. So I'm going to have to know an initial condition. If I don't know the initial condition, and I don't know the initial condition at 0, I can't use Laplace transforms. So if I have a differential equation problem and I know the initial condition at 1, I can't use Laplace transforms for it. So think of Laplace transforms as something that we're going to use to solve time-type problems. I know the initial condition at t equals 0, and I can use it. Think of it that way. If I take the Laplace transform of the second derivative, I end up with s squared f of s minus s f0 minus f prime at 0. So I'd have to know two of them. Although it's not on the table, I could continue the Laplace transform of the third derivative would be s cubed f of s squared f0 minus s f prime 0 minus f double prime 0. So I could continue that same pattern, and I could find a fifth derivative or a sixth derivative in the same way. Okay. So now we're looking through what's in, and we can see that on page 278 where I can do that. And so we look past the other things that are there, hope for the best, and we have a theorem. We have a theorem 2 that says two things are equivalent if I can take the Laplace transform of an integral and that's going to be equal to 1 over s, the Laplace transform of just the function, which would be f of s over s. And that's the same thing as if I were to take the inverse Laplace transform of f of s over s. If I were to do that, then I would get that integral. And this is interesting because just 2 days ago I said something clever like we're going to use Laplace transforms and solve differential equations, and we don't have to integrate and differentiate. All we're going to do is use algebra, right? And then the next section in, we have a theorem telling us what happens if we take the integral of something. So that falls in the face of insanity, right? All right, well, luckily, that's just the way the world is. All right, so I'm looking at the problem set, and I see we have to make it up to 23. So I'll start with number 2. And use Laplace transform to solve the problem. Okay, so I got x double prime, 9x equals 0, x is 0, x at 0 is 3, x prime at 0 is 4. Now, if we weren't in this chapter, we'd say, well, gee, I have a characteristic equation, m squared plus 9 is 0, m is equal to plus or minus 3i, and x of t is equal to c1 cosine 3t plus c2 sine 3t. And then I'd find that c1 is 3 and put a 3 there and find what c2 is later. And so I could do that, right? In fact, I'll continue doing that. I'll solve it just like that. And so x of 0 is C1, which is 3. So I have x of t is equal to 3 cosine 3t plus C2 sine 3t. And I got that x prime at t is equal to minus 9 sine 3t plus 3c2 cosine 3t. X prime at 0 is 4, implying that 3c2 is equal to 4, and c2 is equal to 4 over 3. And final answer, x of t is equal to 3 cosine 3t plus 4/3 sine 3t. Okay, so I could do that, right? I mean, there'd be nothing wrong with that. But unfortunately, I'm not in Chapter 2. Or I could use series approximation, too, if I wanted to. I mean, there's no reason I couldn't. X double prime plus 9x is equal to 0. X of 0 is 3. X prime of 0 is 4. Okay, so that's what I have. I'm going to take the Laplace transform of both sides of the equation, and I'm going to get s squared x of s minus s times 3 minus 4 plus 9 x of s is equal to 0. I'm going to have s squared plus 9 x of s is equal to 3s plus 4. I'm going to have x of s is 3s plus 4 over s squared plus 9. I'm going to have x of s is equal to 3s over s squared plus 9 plus 4 over s squared plus 9. And then I'm going to say, well, you know, I'll rewrite that. S of s is 3 times s over s squared plus 9. I recognize s over s squared plus 9 as equation number 10. So when I do a reverse Laplace transform, I can do that. I recognize this guy as number 8, but number 8 requires a 3 on top, so this is going to be plus 4/3 3 over s squared plus 9. And now I've got number 8. Now I'm going to do an inverse Laplace transform of both sides of the equation, and I'm going to say x of t is 3 cosine 3t plus 4/3 sine 3t. And I'm going to remember that that's exactly what I had before. Okay?
You go a little bit.
That good?
What?
Huh? Is that good? I went up a little bit. I just wondered if that was far enough. Oh.
Right above the collection.
Oh, okay. Yes, we can do that.
Is that s, like s to the third?
No, that's s times 3.
Okay.
So if you look at equation number 3 in your Laplace transforms table, we have s squared Laplace transform f of t minus s f at 0 minus f prime at 0. So that's what I'm doing. That's f prime at 0. That's s f at 0. Okay? All right, well, that seemed okay. Now, the next issue is, given the choice between using the characteristic equation and getting the right answer, or using Laplace transforms and getting the right answer, which one was easiest? And you don't have to answer that yet because you haven't practiced Laplace transforms. But that particular problem, it looked like about the same number of steps. So it really didn't matter which one I used. unless of course I was being told to use a particular one. Number 4, I have x double prime, 8x prime, 15x is 0. X at 0 is 2, x prime at 0 is minus 3. And I've got a characteristic equation, and I can factor it. So if I use the characteristic equation approach from chapter 2, I can factor my characteristic equation m plus 5, m plus 3, and I can say y is equal to c1 e to the minus 5t plus c2 e to the minus 3t, and then I could calculate c1 and c2 for my initial conditions. I could do that if I wanted to, but I don't want to because I'm in chapter 4, but I could. So I'm going to take the Laplace transform of the whole thing, and I'm going to have s squared f of s minus s times s times 2 minus 3 plus 8 times s, going to change that to an x. We use capital X's in case you're wondering, and not little x. That's a little x, that's a capital X, of s minus 2 plus 15 x of s is equal to 0. All right, so I'm going to combine like terms, s squared plus 8s plus 15. Notice that looks extremely similar to the characteristic equation sitting in front of there. I wonder why. Is equal to, I'm going to throw this on the other side of the equation, so I've got 2s minus 3 plus 16. Okay, so x of s, 3s plus 13 divided by s squared plus 8s plus 15. All right, and I look at the bottom and I see, well, that's factorable underneath there, I guess. So I can factor it, so I will. 3s plus 13, and I've got s plus 5, s plus 3. So you want that to be a 2s, like this 2 here should be the same 2 as that 2 there is. Is that, well, you're awful picky, being back in the back row like you are. Front row guys, you were supposed to catch that. All right, so I got that. That's fine. So now what am I going to do? Well, I'm going to look at my Laplace transform table, and I'm going to see that, well, it doesn't look like I have any of those things. But I can do a partial fractions. And I can say that this is going to be a over s plus 5 plus b over s plus 3. And now all I have to do is solve for a and b. How glorious. All right, so I'm going to find a common denominator, and that's s plus 5 times s plus 3. And then on top, I'm going to have as plus 3a plus bs plus 5b. And I'm going to say, okay, the s term is a plus b. And that's going to have to equal 2. And the unit term is 3a plus 5b, and that's going to have to equal 13. And now all I have to do is solve for a and b. Well, let's see. A is equal to 1315 divided by 1315. 5 minus 3, I got a 2 on the bottom. 10 minus 13, I got a minus 3 on top. So if A is minus B, then that means minus 3 over 2, then B is going to have to be 7 over 2. 7 over 2. Okay, so it's 35 minus 9. 35 minus 9 is 24. No, it isn't. Better not be. 35 minus 9 is 26, divided by 2 is 13. So that's right. So I know what B is, I know what A is. Okay, so x of s is equal to minus 3 over 2 divided by s plus, is it 3 or 5? Plus 7 over 2 over s plus 5. I hope I got those in the right order. And I don't. Five, 3. Okay, that's better. And then I take my Laplace transform table, and I notice that that's number 7. Number 7. And number 7. And I now take a inverse Laplace transform of the whole thing, and I end up with x of t is equal to minus 3 over 2 e to the minus 5t plus 7 over 2 e to the minus 3t. Okay, so that's my final answer. Now I go into a checking mode. I look at x of 0 is equal to minus 3 over 2 plus 7 over 2, which is 2, check. And then I find x prime of t is equal to 15 over 2 e to the minus 5t minus 21 over 2 e to the minus 3t. And I find x prime at 0, what is it supposed to be? It's supposed to be minus 3. Why am I not getting minus 3?
It is.
It is minus 3? Oh. X prime at 0 equals minus 3. Check. Well, if the initial conditions check, then the whole problem must be right, so I won't bother to check it any further. So, should I check it further? Yeah, I probably should. X double prime of t minus 50, 75. 75 over 2 e to the minus 5t plus 63 over 2 e to the minus 3t. All right, now I want, this is number 4, so I want one of these guys, 8 of those guys, and 15 of these guys. So I got 45, 75 is 120, and 8 times 15 is 120. That guy goes away, and I have 15 times 7. Okay, so I got 15 times 7 plus 63 minus 8 times 21, and that's 0, 2, so those two terms go away. So we check. 0 is equal to 0, check. So not only did I check the initial conditions, but I checked the whole problem. Okay, good enough? Move up, move down, move sideways. I mean, you haven't ever done this in your whole life, right? So it should be pretty easy because you like learning new things. Number 6. X double prime plus 4x equals cosine t. And I've got everything is 0. So x at 0 is the same as x prime at 0. So that's going to be pretty simple. Okay, so I'm going to take the Laplace transform of everything. I got s, x of s, minus something at 0 minus something at 0, plus 4x of s. And this is a squared, naturally, is equal to. Now, cosine t, I look in my book, and I found out this is number 10, and I get that a s over s squared plus 1. Okay, see I got an s plus s squared plus 1 out of that? Okay, one person is shaking their head yes, the other one's looking around trying to figure out why the other person is shaking his head yes. S squared plus 4 x of s is equal to s over s squared plus 1. X of s is equal to s over s squared plus 1 times s squared plus 4. Okay, now I check my Laplace transform to see if I have anything that looks like that. And lo and behold, I do not. So I'm going to do a partial fraction on this guy and say that this is as plus b over s squared plus 1 plus cs plus d over s squared plus 4. Now, why am I doing that? Well, what goes in the numerator is something that's one less in power than what's in the denominator. Okay, so I got an s squared on the bottom. I need an s and a unit term on the top. Okay, now I'm going to go and put it under some common denominator, s squared plus 1, s squared plus 4. I'm going to have an as cubed plus 4as plus bs squared plus 4b plus cs cubed plus ds squared plus cs cubed ds squared cs plus d. Did I do this guy right? As squared 4as bs squared 4. Yeah, I did. Okay. All right, so I look at that, and this has to be something over s. So I look at the s squared term, and I look at the s cubed term. S cubed term, a plus c has to be 0. I look at the s squared term, b plus d has to be 0. I look at the s term, 4a plus cs has to be 1. I look at the unit term, 4b plus d has to be 0. Now, if d plus b plus d is 0 and 4b plus d is 0, what does that mean? That means that b has to be 0 and so does d, right? There's no other way that that could be. So I solved for b and d already. So now I'm going to solve for a and c. Okay, so I've got a plus c is 0, and I have 4a plus c is 1. Okay, so a is going to be 0, 1, 1, 1, divided by 1, 4, 1, 1. I'm using Kramer's rule again. 0 minus 1 on top. 1 minus 4 gives me a minus 3. So a is 1/3. If a is 1/3, then c had best be minus 1/3, right? 1/3 minus 1/3 checks. All right, so x of s becomes 1/3 divided by something s. Because the a term had an s on it, and then minus 1/3 s, because the c term had an s on it right there. A and c are both s's. S squared plus 1, s squared plus 4. Okay, now I'm going to go and take a inverse Laplace transform of both sides of the equation, have x of t is equal to, and I notice that an s over s squared plus 1 is the number 10 guy, and this guy's going to be the number 10 guy as well. So I'm going to have 1/3 cosine t minus 1/3 sine 2t. No, stupid guy anyway. Cosine 2t. It can't be number 10 getting cosine, number 10 getting sine. That won't work. You know. All right, we'll check our work. X at 0 is supposed to be 0. It is 0. Check. X prime t minus 1/3 sine minus plus 2/3 sine, and x prime at 0 is supposed to be 0. It is 0. Check. All right. We could check the rest of it. We have plenty of time. Might as well check the rest of it, right? We'll start over again. X of t, I'm still checking. X of t is 1/3 cosine minus 1/3 cosine. X prime of t minus 1/3 sine minus plus 2/3 sine. X prime of t, x double prime, minus 1/3 cosine plus 4/3 cosine. And when we get done, we want to have cosine t. That's what we want to have when we get done. And we have 1 of this guy, and we have 4 of that guy. All right, well, 4/3 minus 1/3 is cosine t. 4 minus 4/3 plus 4/3 is nothing, and we check. Okay? Problem so far? All right. Moving on. Number 8. Now, are you guys supposed to be doing everyone? Yes, everyone. So I have to do everyone. You guys are supposed to be doing everyone odd, so I'm going to do everyone even. Now, after you do everyone odd, if you have some problem, then ask me to solve them, right? But don't ask me to solve them if you haven't done them yet. X double prime plus 9x equals 1. Now, a problem very similar to this is going to be on your next test, and you're all going to miss it. Well, except for Andrew. Which one? I don't have to say, do I? Anyway, you're all going to miss it because you're going to miss something. All right, so I'm going to take the Laplace transform. I'm going to have s squared, s of s, minus the first guy, which is 0, minus the second guy, which is 0, plus 9x of s. And this is where you're going to mess up because this is a 1 over s, and you're going to forget that. All right, so I'm going to s squared plus 9 x of s is equal to 1 over s. I have x of s is 1 over s squared plus 9. Okay, so do I have a Laplace transform with an s squared plus 9? Yeah, I do. You see it? Number 22. 22 is the guy that I had. Now, with number 22, what's required is to have the 9 on top. So I'm gonna rewrite this guy to be 1/9 9 over s squared plus 9. And then I'm going to take the inverse Laplace transform of both sides. X of t is equal to 1/9 1 minus cosine 3t. X of t is equal to 1/9 minus cosine 3t. Now x at 0 is supposed to be 0, right? It wasn't before, but it is now. So x at 0 is 0, and y at 0, and x prime at 0 is 0. Yeah, that's going to be true too. So the initial conditions work. So we'll see whether or not the problem is solved. So that'd be 1/3 sine 3t, and x double prime would be cosine 3t, and I want this number 8, want one of them, 9 of those, and when I get done I want to have 1. Okay, so that's the plan. All right, so I have a 1, and I have a cosine 3t, a minus cosine, a plus cosine, plus 0, check. So the initial conditions check, the problem checks. I'm all set. Going on to number 10. So number 10. X double prime, 3x prime, 2x is equal to t. Is that what it is? Really? Yep. And I have x at 0 is 0, which is convenient. X prime at 0 is 2, which is less convenient, but still within my ability to solve the problem. Okay, so I got s squared x of s minus s times 0 minus 2 plus 3x of s minus 0 plus 2x of s is equal to 1 over s squared. So the t, if I look at number 5 in my Laplace transform table, I see the t becomes 1 over s squared. If I don't remember that, that's where I get that from. Okay, I've got an s squared plus 3s, there's an s there, plus 2 x of x is equal to 1 over s squared. And then I've got x of s is 1 over s squared plus 3s plus 2. Okay, and I recognize as 1 over s squared, s plus 2, s plus 1. And I look into my Laplace transform table to find that particular person, and I see that the author has hosed me over, and I don't, huh?
Where'd the 2 go?
What 2?
You scroll up there, is that minus 2?
This 2 right here?
No, up farther.
Right
Right there between the s squared and the 3s and minus 2.
That minus 2 that I forgot about
Okay.
altogether and I didn't do anything with, plus 2. That 2 right there?
Yeah.
A good thing you caught me before I went too far. All right, now I gotta do something else now. All right, so I've got 1 over s squared plus 2. All right, so I'm going to multiply both top and bottom by s squared. So I'm going to have 2s squared plus 1 over s squared not s squared, s plus 2s plus 1. And again, I'm going to look at that and say, well, I don't have a Laplace transform that does that, but because the instructor has gone and used partial fractions forever and ever, we're going to continue to do that. So we're going to have a over s plus b over s squared plus c over s plus 2 plus d over s plus 1. Now, is that really the way I'm supposed to do that partial fraction? I'm pretty sure that that's the way I'm supposed to do it. And so I'm doing a partial fraction there. And yeah, I'm pretty sure that's the way it's supposed to be. So I wouldn't have a bs plus c up there. I wouldn't do that. I'm pretty sure I don't do that. Well, we'll see. If it doesn't work, then we'll go find it in the right place in the book and do it right. But I'm pretty sure that's right. Okay, so now I'm going to find a common denominator. And my common denominator is going to be s squared s plus 2 s plus 1. So I'm going to have an a s cubed plus 3 as squared plus 2 as plus bs squared plus b 3bs plus 2b plus c s squared plus d s squared. So now did I do that right? Yeah, that's right. That's a good look there, Andrew. I like that one. Gee, how would I know? All right. So now we're gonna we got to see. Okay, so I say okay, I got that. All right, so I'm looking at the s cubed term. A. That's the only s cubed term there is. And it has to be 0. Okay, so now I'm looking at the s squared term, 3a plus b plus c plus d, and that's going to have to equal 2. And then I'm looking at the s term, 2a plus 3b, and that's going to have to equal 0. I'm pretty sure. The s, yeah, there's no s term. So b is equal to 0 imply this is 0, that's 0, implies b is also equal to 0. Oh, I don't know if I like this. And then I'm going to look at my unit term. My unit term, where's my unit term? 2b, which is also equal to 0. So b is 0, a is 0, and c plus d is 2. Is that what you're trying to tell me? That seems rather unlikely. So what did I do wrong? What did I do wrong? This would be s. As squared, 3as plus 2as. B, bomb. That's what I did wrong. Bummer. See what I did wrong? I ran out of room. That's what I did wrong. And because I ran out of room, I decided to take a shortcut that was wrong. So I'm going to move this way over here. Okay, so this one has to be CS cubed plus CS squared. And this term has to be DS cubed plus 2DS squared. Okay, so maybe I did that right this time. And so we need a bigger than normal eraser to get rid of all this junk down here. All right, so now I'm looking at the S cubed term. I have an A and I have an C. A plus C is 2. Looking at the S squared term, 3A plus B plus C plus 2D has to be 2. I'm looking at the S term, 2A plus 3B has to be 0. I'm looking at the unit term, 2B, which has to be 0. Oh, I feel like I am so rejected from the truth.
There's supposed to be a D in that S cubed.
S, yeah, I guess so. Plus D equals 0. Alright, plus 2D. The only unit term is going to be that B. Yeah, I guess so. And so looks like B is 0. B is equal to 0, and then I got A is equal to 0. And then I got that I have B plus, no, B is 0. Oh, that would be good, wouldn't it? Wouldn't it be wonderful if that was equal to 1? Yeah, equal to 1. Okay, so B is equal to 1/2. Okay, if B is equal to 1/2, then A is going to be equal to what? A is equal to, B is 1/2. A is going to equal to 3/6 minus 3/6. 3/2 minus 3/2. Okay, well that's good. I'm happy about that. All right, so now I've got that C plus D is equal to 3/6. And I've got that C plus 2D is equal to 2 plus 2/3 minus 1/2. And this is 3/2 minus 1/2. So that'd be 3. And this is a 1/2. And this is a minus 1/2. How come I didn't have minus 1/2 there before? Is A going to be minus 1/2? No. If B is 1/2, if B is 1/2,
Would be 1/3.
what, for this guy?
Yeah. Because 3 times half is 3/2. What gives then get 2/3?
Okay, so B is 1/2. That'd be minus 1/2. Minus 3/2. Minus 3/2. 6 over minus 3/2. Oh, bummer. Seems to me like I ought to better do that in my head. B is 3, is 1/2. So I got 3 halves. I got minus 3 halves. I got minus 3 quarters for A. Okay. Now that I have A as minus 3 quarters, I can do these guys again because A is in them. Okay, so now I have C plus D is 3 quarters. C plus 2D is 2 plus 9 quarters minus 1/2. If this is a plus sign, is that a plus sign? Yeah, it has to be. All right, so what's 2 minus 9 quarters, 2 plus 9 quarters minus 1/2. Okay, so that's 3 3/4. 15 quarters. 15 quarters. All right. So that being the case, C is going to equal 3 quarters, 15 quarters, 1 2 divided by 1 1 1 2. I'm dividing by 1. All right, so I've got 6 quarters minus 15 quarters would be minus 9 quarters. So C is going to be minus 9 quarters. If C is minus 9 quarters, then that implies D is going to have to be, what's 9 in 3? 12? It's going to have to be 12 quarters, also known as 3. Okay, so now I'm ready to write things down. Anybody remember what A is? Okay, so I got minus 3/4 over S. That's A. B was 1/2. 1/2 S squared. Okay, and C is minus 9 quarters over, is it S plus 2?
Yeah.
And then D would be 3 over S plus 1 is equal to S of S. Okay, and now I'm going to take the inverse Laplace transform of everything. Normally I put it on the other side, but because I ran out of room over there, I didn't do that. Okay, so we look at our table. This is the number 4 guy, the number 5 guy, and the number 7 guy. So we get x of t is equal to minus 3/4 minus 1/2 t minus 9 quarters e to the minus 2t plus 3 e to the minus t. Okay, now we go into a checking work. X of 0 minus 3/4, that goes away, minus 9/4 plus 12/4 is 0. Check. Was that guy 0? Yeah, it was. Okay. And then x prime of t minus 1/2 plus 9/2 e to the minus 2t minus 3 e to the minus t, and x prime at 0 is supposed to be 2. It's supposed to be 2, and this is 6, 7. 7 minus 9, 2/2. That doesn't check. Oh, what a bummer. That's not checking. Why is that not checking? Okay, I took the derivative right. One half from there is 4. 4 minus 3 does not check. Okay, can we find our error, or must we just start over? Okay, we'll see if we can find our error first. S squared minus 2, okay, minus 2, 3s x squared 2 x of s 1 over, oh, look at that. Okay, that's right, 1 over s squared. Okay. So that's right. I collect the like terms and I put that over there. I multiply top and bottom by s squared and I get that. I'm going to make a partial fraction a over s plus b over s squared plus c over that plus d over that. Okay, so I got to multiply this times s to get that guy. as cubed 3as squared 2as. I need that times that b, b, b. Okay, I need this one plus an s squared. cs cubed plus cs squared. ds cubed plus 2ds squared. Okay, so that looks right. I look at my s cubed term, a, c, d. S squared term, 3a, b, c, 2d is 2. I look at my s term, 2a, 3b, nobody else. I look at my unit term, 2b or not 2b. Okay, so b is a half. Okay, I agree, b is a half. 3/4 minus 3/4 minus 3, 3 halves minus 3 halves. So that's that. All right. I didn't multiply it times 3. No, I didn't. I don't have to. CA minus 3/4 CA. Okay, so that one's right. So I got C. I got 2D. I have a 2 plus 9/4 plus 9/4 minus a half. Okay, I've got 8, 17, 17 minus 2, that's 15/4. Okay, 15/4. 6 take away 15 is minus 9/4. 2 take away 1 is 1. Minus 9 over 9. Okay, minus 9 over 9. 9 plus 3 is 12. Divided by 4 is 3. Looks like I did all that right. A is minus that, B is that, C is that, D is that. First guy checks. I take a derivative. That's right. I take the derivative, put it out in front, plus 9 over 2. 9 over 2. I put it out as far as minus 3. X prime at 0 is 2. 2. Minus a half minus 6 halves is minus 7 halves. That's still a 1 when it's supposed to be a 2. We'll move to the back of the book and see if we can get a little bit closer to where our mistake is. 4-2, number 10. Okay, I'm supposed to have minus 4/3. Okay, I got minus 4/3. I'm supposed to have plus a half. Why does the book say plus a half and I have minus a half? Okay, so we'll move back up. B is plus a half. Why do I have a plus a half there and I have minus a half here? How did I go from that to that? Boom. Much better. Okay, now that I've done that, this becomes plus a half. Now that that becomes plus a half, this becomes 10 halves minus 6 halves. This becomes a 2. Check. Okay. Good enough. Moving on to 12. Well, yeah, we'll move on to 12. We have plenty of time. Number 12. X prime plus x plus 2y. Now what in the world? X prime equals x plus 2y. Y prime equals x plus e to the minus t. Is that what my eyes are showing me? Okay, I guess so. X at 0 is equal to y at 0 is equal to 0. Okay, well, I mean, what do we know? All we know is how to take the Laplace transform, so we might as well do that, right? All right, so I've got s of s x of s is equal to x of s plus 2y of s. And then I've got y of s is equal to x of s plus 1 over s plus 1. This is from number 7. Number 7. Okay. That looks okay. What are we going to do with that? Well, you know, we're going to line everything up. So we're going to have the x of s's in a column there, the y of s's in a column there, and everything that isn't in a column there. On the other side, when we get done, we're going to have something that looks like x plus y is ax plus by is equal to c, cx plus ey is equal to f, right? And then we're going to solve for x of s and y of s independently. Okay, that's our plan.
Why isn't it S, Y of S?
Where?
In the second
Here?
equation. Yeah.
All right, that's better. Okay. So I've got s minus 1 x of s minus 2y of s is equal to 0. Okay, and then I've got minus x of s plus s y of s is equal to 1 over s plus 1. Oh, hope I did that right. Okay, I probably did that right. Okay, using Kramer's rule, we find that x of s is equal to 0, 1 over s plus 1, minus 2s, divided by s minus 1 minus 1 minus 2s. That guy's 0, this guy's minus a minus. So I have 2 over s plus 1 divided by s squared minus s minus 2. Is that what I have? Yes, I do. Now I'm gonna write down y of s while it's close. Alright, so on the bottom I have s squared minus s minus 2 because that's not going to change. And on the top I have s minus 1 minus s, and then I have 0, 1 over s plus 1. Okay, so I've got, that's a 0. So I've got s minus 1 over s plus 1 divided by s squared minus s minus 2. Okay, you happy with that? Oh yeah, just totally peachy. Now, assuming we didn't make a mistake, which of course we didn't, right? We didn't make any mistake. I'm going to solve for y of that x of x first. So x of x equals, darn, need the pointer first before I do that. Equals that. Alright, so I have x of x equals 2 over s plus 1 times s minus 2 times s plus 1. Okay, so I got 2 over s plus 1 squared s minus 2. Oh, tell me I got that one. I don't. Alright, so I got to do partial fractions. A over s plus 1 plus b over s plus 1 squared plus c over s minus 2. Okay, on the bottom I got s minus 1 squared times s minus 2. And on the top I have a times s plus 1 times s minus 2 plus b times s minus 2 plus c times s plus 1 squared. Okay, that way I can figure it out later, right? So I got as squared minus as minus 2a plus bs minus 2b plus cs squared plus 2cs plus 1c. Now why would I write 1c for? That seems kind of ridiculous, 1c. Divided by the common denominator. Okay, so I'm looking at the s squared term. I have an a plus c, and I see my a plus c is going to be 0. I'm looking at the s term, minus a plus b plus 2c, and I see that it has to be equal to 0. I look at the unit term, minus 2a minus 2b plus c, and it has to be 2. Okay, now I could go get my spreadsheet that solves this for me. That's probably what I should do. I look at this and say A is equal to minus C. Okay, so I'm going to have B plus 3C is 0, and minus 2B plus 3C is 2. Okay, and then I'm going to have B is equal to 0, 2, 3, 3 over 1 minus 2, 3, 3. 0, I have a minus 6 on top. Minus 3 and 3 minus 6 is minus 3 on the bottom. So B is 2. Okay, so if B is going to be 2, then C had best be minus 2 over 3. And if C is minus 2 over 3, then A had best be plus 2 over 3. Okay, so I'm all set. X of t, oh, yeah, x of t, right, is equal to what? A. All right. 2 over 3? 2 over 3 s plus 1. Okay. Plus b, which is 2 over s squared plus 1, minus 2 over 3 divided by s minus 2. S minus 2? S minus 2. Okay, I recognize this guy as number 7. I recognize this guy as number 8. And I recognize this guy as number 7. All right, so I have, this is x of s still. So I'm going to do an inverse Laplace transform, and I end up with x of t equaling 2/3 e to the minus t plus 2 sine t minus 2/3 e to the 2t. Okay, well that seems okay, I guess, all things being equal. X at 0, is x at 0, 0? X at 0 is 0, so that's a good thing, check. Alright, that's all I can check right now is that x at 0 is 0. Alright, now we're going to solve for y of s. So we got x of t, but now we got to go back up and get, where's y of s? There's y of s. Copy. And so y of s is that guy. Okay, so I've got y of s is s minus 1 divided by s plus 1 times s plus 1 times s minus 2. Is that what I have? Really? Really? Yeah, I guess so. Okay, so I'm going to have a partial fraction a over s plus 1 b over s plus 1 squared and c over s plus minus 2. All right, and I do the common denominator thing. I get a s plus 1 s plus 2 minus 2, and then I get b s minus 2, and then I get c s plus 1 squared over my common denominator, which I'm not going to write down again. Alright, so I got as squared minus as minus 2a plus bs minus 2b plus cs squared plus 2cs plus c over my common denominator. All right, so I look at the s squared term and I find a plus c is 0. I look at my s term, I find minus a plus b plus 2c is equal to s1. I look at the unit term, minus 2a minus 2b plus c is equal to minus 1. Where is it? Minus 1 right there. Okay, well, that seems reasonable. Is that reasonable? We'll do the same thing again. We'll say a is equal to minus c. So we're going to rewrite this guy as b plus 3c is equal to 1. And minus 2b plus 3c is equal to minus 1. And b is equal to 1 minus 1, 3 divided by 1 minus 2, 3. Okay, on the bottom here I've got 3, I got a minus 3. Set 3 plus another 3 is 6. So this is, I got minus 2 for b. Okay, what? Not right? Okay, minus 2 is b, so c is going to be 2 over 3. No, it's not. 1 over 3. 1 over 3? No. 4 over 3? No. Well, wait a minute. It's going to be 1. There we go. If b is minus 2, then c has to be 1. All right, so I know b, I know c. If c is 1, then a is going to be minus 1. Okay, so I have y of s equals minus 1 over s plus 1 plus minus 2 over s plus 1 squared, and c is what? 1, plus 1 over s minus 2. I'm using number 7, did I do that wrong? Oh, bummer. It's s plus 1 squared, not s squared plus 1. Alright, so that's not right. This is s plus 1 squared. And s plus 1 squared is number 15. And number 15 is going to make this t e to the minus t, 2t to the minus t. Okay? And x at 0, this term is still going to go away. I'm still going to get 0. It's still going to check. Okay, so now we come back down here someplace. Where to go? Just shake the whole thing away. So this is number 15, and this is number 7. And I have that y of t minus e to the minus t minus 2 t e to the minus t plus e to the 2t. And y at 0 is supposed to be 0, and it is 0, so that checks. Okay, so recapping, x of t is equal to, wow, x of t, where'd x of t go? There it is. 3, oh there, we'll just copy and paste it. Okay, so there's x of t. Where's my paste thingy? So there's my x of t. And where's my, then there's my y of t. Can I get them both in the same frame? Yes, I can. Y of t is equal to minus e to the minus t minus 2t e to the minus t plus e to the 2t, and I'm missing this term. Anybody remember what that term was?
It's the opposite of the line.
2t e to the minus t. 2t e to the minus t. All right, so now those are my final answers. I'm now going to check my work, and I want x plus 2y. Okay, so x plus 2y. Okay, so I've got minus 2. Okay. Okay, so minus 2y. So I've got 4/3 plus minus 4/3 e to the minus t. I got 2 minus 2, so I got minus 2t e to the minus t. I got 2 of these, so that's 4 plus 4/3 e to the 2t. And that is supposed to equal x prime. And x prime is minus 2/3 e to the minus t minus 2 e to the minus t minus 2t e to the minus t plus 8/3 e to the 2t. Not even close. How did I get 8/3? Oh, bummer. What am I doing? Okay, supposed to be equal to that guy, the derivative of that guy. So that'd be minus 2/3 e to the minus t plus 2 e to the minus t minus 2t e to the minus t minus 4/3 e to the 2t. This guy is the same as that guy. This guy is not the same as that guy. Who is not the same as that guy. Bummer. Now we got to go. But we're close. If I had a minus sign here, I'd be okay. All right, so let's move up. Okay, 2t is right. Well, c was supposed to be 1. There's a minus there, there's a minus there, there's a minus there, a minus there. Did I write it down right? All right, back to the back of the book for a moment to see where to concentrate our efforts in finding our mistake. For 1, this is number 14. No, it's not. 4-2. 4-2, number 14. X prime. Are we doing number 14? We better not be.
I think it's 12.
We're doing 12? That's much better. So this is supposed to be 2/9 e to the 2t. And it's supposed to be 2/9 e to the minus t. And it's supposed to be, so t is wrong. And this guy here is 1/9. And y is wrong. Both of them are wrong. Well, seeing that they're both wrong, there's no reason to worry about it. And this is where I run into problems because I can't see enough of the problem. So, what's your pleasure? Do it all over from scratch or move on to the next problem?
Next one.
Next problem? Okay, so we're going to do now 14 only has 2 variables. You want to do 16 because it has 3 variables. That looks like more fun. Okay, so we'll move on to number 16. Okay, so I've got x prime is x plus z. And y prime is x plus y. And z prime is minus 2x minus 2z. And all of them are 0 at their first derivative. And I'm going to take a Laplace transform of the whole thing. Okay? So I'm going to have s, x of s, is equal to x of s plus z of s. And I'm going to have s, y of s is equal to x of s plus y of s. And then, good going there, I can't see anything. S, z of s is equal to minus 2 x of s minus 2 z of s. Am I doing the right problem? No, I am not. Yes, I am. No, I'm not. X of 0 is 1. Y of 0 is 0. Z of 0 is 0. Okay, now I'm doing the right problem. So this is minus 1. Now, talk about a correction, you know. That was definitely a manly correction there. Saying that the other way I'd have x plus y plus z and 3 equations, 3 unknowns, everything equal to 0, right? And if I did, then I wouldn't have a real problem. So, but that's the only place I'm going to have a minus 1. So, okay, that's good. Okay, now I'm going to write it as s minus 1 x of s minus z of s equals 1. And I'm going to write it minus x of s plus s y of s s plus 1. S minus 1. S minus 1. S minus 1 y of s is equal to 0. And then I'm going to write it 2x of s plus s plus 2 z of s is equal to 0. Okay. Now I've got 3 equations, 3 unknowns. I have a plus 0 y of s sitting there, a plus 0 y of s sitting there, a plus 0 z of s sitting there. So you can see what it is. And then I'm going to say x of s equals s minus 1 minus 1, 2, 0, s minus 1, 0, minus 1, 0, s plus 2, divided by that was just so good. I just don't believe I did that. 1, 0, 0. Okay. Divided by s minus 1 minus 1, 2, 0, s minus 1, 0, minus 1, 0, s plus 2. Okay, so on the bottom I only have this guy minus that guy, right? So the only thing I have on the bottom is s minus 1 squared s plus 2 minus a minus, so it makes it a plus 2s minus 2. Okay, on the top I've got that one's 0, this one's 0, everything else is 0. So the only thing on the top is s minus 1 s plus 2. That's all I've got on the top. Okay, now I'm gonna look at this denominator. Well, I'll rewrite it. S of s is equal, like I said, I got s minus 1, s plus 2, and on the bottom I have s. Okay, what do I have? I've got s squared minus 2s plus 1, s plus 2 times plus 2s minus 2. Okay, I've got s minus 1, s plus 2, s cubed minus 2s squared plus 2s squared minus 2s squared. They go away. I got minus 4s minus 4s plus s plus 2 plus 2s minus 2. Alright, so I got s minus 1, s plus 2, I got an s cubed, I got a 4 minus, I got a minus s, the other guy goes away. Okay, I've got a s plus 2 divided by, I can factor out an s, and then I get an s squared minus 1. The s squared minus 1 goes away, and it's going to be s plus 1 on the bottom. Okay, so that's my x of s. Right, so now we're working on the y of s. On my bottom guy, I'm going to have the same exact thing on the bottom, which is s cubed minus s. Okay, on the top, I'm going to have s minus 1, minus 1, 2, 1, 0, 0, minus 1, 0, minus 1, 0, s plus 2. that's 0, that's 0, this one's 0, that one's 0, that one's 0. This one, the only one that's not 0 is the minus with the plus sign. So I'm going to s plus 2 over s plus 1. So I have the same one. Y, x and y are the same answer. No, they're not the same answer. No, they're not the same answer. S plus 2, and this guy's going to be s times s squared minus 1. Okay, so those are two different things. All right, so z of s, I'm going to have the same s cubed minus s on the bottom. I'm going to have s minus 1, minus 1, 2, 1, 0, 0. And the middle guy is 0, s minus 1, 0. Okay, I got s squared minus 1 on the bottom, 0, 0, 0. That guy is not 0, everybody else is. So the only guy that isn't 0 is minus 2, s minus 1. It's the only guy that isn't 0. And this guy becomes minus 2, s plus 1. All right. So, recoup. X of s is s plus 2 over s plus 1. Y of s is s plus 2 over s squared minus 1. And z of s is minus 2 s plus 1. Okay, so now we're looking at our Laplace transform tables, and I've got an s plus 1, and I've got, do I have a s plus something, s plus 1 on the bottom? Okay, so I have the z guy. Okay, so I'm going to do z first. So z is equal to minus 2, 1 over s plus 1. And that, using number 13, I find that z of t becomes minus 2, 1, minus e to the minus t. Okay, so I have z. Now I got to work on y and x. Which should we work on first? Guess we'll work on x first. X of s plus 2 s plus 1. Okay, we'll do a partial fraction. A over s plus b over s plus 1. And so I've got a plus bs over s plus 1. Okay, so a plus b has to be 1, and a has to be 2, implying that b has to be minus 1. So x of s equals 2 over s minus 1 over s plus 1. X of t is equal to 2t, just 2 minus e to the minus t. All right. Is z the guy we're working on, or y? Y is next. Okay, so y of s equals y of s equals s plus 2
over
s
S plus 1.
s plus 1 s minus 1. Okay, we'll do a partial fraction. A over s, b over s plus 1, c over s minus 1. Okay, so I've got a s squared minus a plus b s squared minus bs plus cs squared plus cs over s plus 1, s minus 1. Okay. I'm looking at the s squared term, a plus b plus c, and I see that it has to be 0. I look at the s term, I get minus b plus c, and it has to be 1. I look at the unit term, and I see minus a minus a. That's the only one. Minus a, and it has to be 2. So that implies a is minus 2. Okay, so I got a is minus 2. B plus c is 2. Minus b plus c is 1. So I got that b is 2 over 1, 1, 1. 1 minus 1, 1, 1. 2 on the bottom, 1 on the top, so b is a half. All right, so if b and a half is a half, then c is 3 over 2. And y of s is equal to minus 2 over s minus plus 1/2 over s plus 1 plus 3/2 over s minus 1. That's correct. Okay. And y of t is going to be minus 2 plus 1/2 e to the minus t plus 3/2 e to the t. Okay. So now we solve for everything. Now we got to check it. X of t is equal to 2 minus e to the minus t. 2 minus e to the minus t. X at 0 is 1. Check. Okay, y of t is equal to minus 2 plus 1/2 e to the minus t plus 3/2 e to the t. Y at 0 is 0. Check. Z of t is equal to where's z of t? Minus 2 plus e to the minus t. 2e to the minus t. and z at 0 is 0, check. Okay, so all our initial conditions check. All right. We're working problem 16, x prime. Okay, so x prime is going to be e to the minus t. That's supposed to equal x plus z. X plus z, check. Okay. Y prime is equal to. Y prime is equal, that goes away, minus 1/2 e to the minus t plus 3/2 e to the t. Okay, that's supposed to equal x plus y. X, that goes away, plus y, check. That checks too. Z prime is equal to minus 2 e to the minus t. Okay, and that is supposed to equal 2x minus z. 2x minus z. 2x minus z is just going to be a 2. 2x minus 2x minus z, that's going to give me a minus 2x minus z. That's going to give me a minus 2 minus 2x minus z. That's going to give me a nothing. That's not going to give me that. This does not check. Does. DOES does not check, I don't think. It's far too late in the day to know, but it doesn't look like it. Okay, so 4.2, number 6, is this 16? We're not doing 16, are we?
Yeah.
Wow. Yeah, that's a bummer doing 16. 16 says it's cosines and sines. And I don't have any cosines and sines at all. Well, that makes 2 in a row. 2 in a row wrong. Oh, that is a bummer. And we don't have any time to correct it, probably. I know I've done these right before. That'll teach me. Okay, time to go home. We'll, of course, amend the audio and the video to protect the innocent.